to try and specify where you would put the matter and what kind of stuff you'd put there to make the geometry fold in that way. And you can do it. So you can write down that geometry. So it's called a warp drive geometry, I think it's called. It's in textbooks. So you can do that to have a warp drive. The question becomes, what sort of stuff would you have to actually put into the real universe to make it warp in that way? And it usually turns out that it's the kind of stuff that doesn't exist, right? But it has properties. It's sort of matter or sort of energy that has properties that do not exist in nature as far as we can tell. But you can still write the geometry down in Einstein's theory.
So if you had the significant force or mass or whatever it is, if you had that stuff that doesn't exist, it is a concept that
so the geometry exists. So you can do it, and you can do the calculations, and you can see the warp drive. You can construct wormholes that connect distant regions of the universe, which you could use as time machines. You can do all that in the theory, but in nature, you'd have to have the right stuff to do it.
But that stuff is not real.
That seems to be
as far as we know.
Yeah.
Now, what would have to happen? Like you would have to have enough power or mass to be able to fold those two things together?
It tends to be weird stuff, like stuff that has a negative pressure or something like that. So stuff that has physical properties that are just bizarre, and that no matter or energy that we know of in the universe has. So that to make the geometry happen.
But it's conceivable in theory that this could exist, even though it doesn't.
It's a debate ultimately. So wormholes are a good example. So that would be quite literally, we talked about the surface of the Earth. So you fly to Australia from LA and you have to go quite a long way around the edge of the Earth. Or you could tunnel straight through and get there quicker, right? So that's a wormhole.
Jamie's got a little graphic up there on the
There it is. There's a wormhole. So you could go all the way around the edge, or you could take the shortcut. So the question is, so you can do that in Einstein's theory. You can write down that geometry, and there it is. So the first question is, can you make it? And as we said, we don't think that stuff exists.
Right.
There's a second set of bits of theoretical work, which are, if you had a wormhole, then what would happen if you tried to travel through it? And what seems to happen is that they become unstable the moment that anything tries to go through. So you get kind of a feedback of stuff going through and through and through and through, and so it collapses. And there's a great book by Kip Thorne, actually. We just mentioned him. He got the Nobel Prize last year for the gravitational waves. And he wrote a brilliant book, I think it's in the 80s, called Black Holes and Time Warps, where he talks about the answer is we don't fully know, but most physicists think that even if they existed, they would be unstable. And as soon as you even tried to transmit information through them, send a bit of light through, then there would be this sort of feedback and they'd collapse. And ultimately, the reason we don't really know absolutely is because you need what's called a quantum theory of gravity, and we don't have one. So we don't have the theoretical tools to be absolutely sure that these things would be unstable or don't exist in nature. But we strongly suspect that they don't. If they did, you could build a time machine. So Stephen Hawking wrote a paper called the Chronology Protection Conjecture. And conjecture is the important word. So the conjecture basically was that the laws of nature will be such that you can't have stable wormholes and you can't build time machines.
And if you sent something through it, it would destabilize it.
Yeah.
And if it didn't destabilize it, how would your physical body deal with the stress of that?
Well, it doesn't have to be that you can build them. That's called the tidal gravitational force. So it's the difference in gravitational pull across your body, which is one of the things that gets you if you fall into a black hole. So before you actually get to the singularity, you can get, it's called spaghettified as a technical word. So you get, and it's just like the moon's, the tidal effects on the Earth, which are quite small, but they still raise tides on the oceans. So that can be if you think about something like a black hole, that can be a massive difference in gravitational pull from your head to your feet, and so it can stretch you out. And so, but you can with wormholes, you can write the geometry down in Einstein's theory such that you could go through. So you don't have to be destroyed or anything weird happen to you.
Would you have to have something protecting you, some force, some sort of a.
No, you just literally you fall through. I mean, so you know, if they would exist, you just go through. You sit in a little spaceship, but you wouldn't. There's nothing inherently in them that says that you would be ripped apart or anything like that. But
what are your thoughts on alien life, on life outside of this planet? Is this something you think about?
Yeah, I think there must be. Even in the solar system, I would not be surprised if we find microbes on Mars or on some of the moons of Jupiter or Saturn where there's liquid water.
Like Europa.
Yeah. And the reason is, that if you think about, the reason I think that, and it's a guess, is because if you look at the history of life on Earth, then, so Earth formed and it was just there was no life. It was a ball of rock. And almost as soon as it cooled down, we see evidence of life. So certainly 3.8 billion years ago, possibly even further back than that, we see evidence of life on Earth. So somewhere along the line, geochemistry, active geochemistry became biochemistry on Earth. And we have some idea, that if you get gradients of temperature and acid and alkaline and the conditions that are naturally present on the surface of oceans, then complex carbon chemistry spontaneously happens. So we know that life, almost certainly we know that life began on Earth. I mean, the other option is it came from space or something like that, but it probably didn't, right? It probably began on Earth. So that means that at least here, that happened. And that we know that the conditions that led to the origin of life on Earth were present on Mars 4 billion years ago. And we know that they're present on Europa today. So I don't see that there's anything special. Life is just chemistry. And the idea that geochemistry becomes biochemistry is not fanciful because it happened here. So I think that given the same conditions, it would be surprising to me if the same thing didn't happen, in that life begins. So that's one of the, to test that is one of the great frontiers of science now. It's one of the great challenges, which is why another reason we're interested in Mars, because we know those conditions were there. We know there were what's called hydrothermal vent systems on the floors of oceans on Mars 3.8 or 4 billion years ago. So it would be good to know if what I've said is right. And the way we find out is to find life or evidence of past life.
Are you aware of the speculation that was going around? How recent was it, that Occupy thing, the octopus eggs? There was a group of scientists that were speculating that it's panspermia, the idea of panspermia, that it's possible that octopi had come from somewhere else. Some frozen eggs had actually come from somewhere else and landed on Earth. And these were like legitimate scientists that were contemplating it, not morons.
I don't think...
Have you seen this?
No, I didn't. But I mean, I think it's unlike... So panspermia